Hello and welcome to BioRules video lessons. Today we are going to be talking about membranes, specifically cell membranes. So you saw in the structure of prokaryotes and eukaryotes that they have membranes surrounding them. You saw that mainly eukaryotes have lots of membranes inside, making the organelles, separating the organelles from other organelles and from the cytoplasm. But what are those membranes? What are they made of? How do they work? So that's today's class. So, first thing, membranes are thin. This is very auto-explanatory. They are flexible, also quite easy to grasp. And they are fusible. Fusible means that a membrane can fuse with another membrane. They can touch and they can become one. And membranes also contain proteins. Okay? So, if we take a look on a very magnified enlarged electron micrograph of a membrane, we'll see that image. So that image over there, with the knowledge that membranes are lipidic in nature, they're made of fat. So we can grasp a piece of that and we can do a biochemical analysis and we realize that it's made of fat. So membranes are made of fat, among other stuff, but they're made of fat. And another thing that we can see in this image is that they have this thick disposition. So how does it work? So let's take a look on the idea of making a membrane with fat. So first thing, very important, new word, is that membranes are made by amphipathic phospholipid. Actually, two new words. Amphipathic means that this molecule is dual in nature. It is at the same time hydrophilic, which loves water, and hydrophobic, which hates water. So the same molecule loves and hates water at the same time. Part of it loves, part of it hates. And it's a phospholipid. Phospholipid is a lipid that contains a phosphate, which is a phosphorus molecule. Okay? So fat is most always hydrophobic. You probably know that because if you get a molecule, for example, triglycerides that you know as fat, that you know as olive oil, for example, if we put oil in water, you know this by experience probably, that they don't mix. Oil and water don't mix. So oil, fat, is almost always hydrophobic. They don't like water. They don't mix. They run away from water. You can put fat inside the water and they're going to run away from it. However, phospholipids are a different kind of fat. Okay? Membrane lipids, they are both hydrophobic and hydrophilic at the same time. So they like water, they hate water at the same time. And that's because of this molecule that makes the membrane. This is the phospholipid. So lipid is this part over here. This is the lipidic part of this molecule. And this here is a phosphate. Actually, you have a phosphate head, which has a phosphate in another stuff over there called a choline, that kind of likes water. If you see this enlarged, it will look like this. So the hydrophobic, in a technical biochemical name, is a non-polar part of the molecule. And this here makes it not to like water. And you have a polar, which is hydrophilic part, which contains the phosphate head, and the choline, that will make it to like water. You will learn more about lipids and the biochemical structure and the atoms that make them later in biochemistry. But for now, this is your first introduction to a lipidic molecule that's going to be very important in cells and in life. Okay? Phospholipids, this image here you already saw. That's the one that I just showed to you. Okay? It's made by all those atoms over here. And if you see here, we have a phosphate, okay, with a choline over there. And it has two tails, one and a crooked one over there. In a lazy biological representation, we are going to be representing phospholipid as a ball. This is hydrophilic, it likes water. And a tail, actually two tails, and this part is going to be the hydrophobic, it don't like water. So from now on, this ball and two tails is the one that we're going to be using most to represent phospholipids into the membranes. Okay? So if we throw phospholipids on water, on the surface of water, this is what happens. They make a film, one molecule thick, with the heads facing down and with the tails facing outside of the water. So the tails hate water, they stay outside, but the heads, they like water, so they stay embedded in water like that. On the surface, quite easy, that's what happens. But what happens if we throw a phospholipid inside of water over here? So the tails cannot run away from water because water, the water is all around, and running away, it would be too far away. So how do they behave? Okay, so basically what will happen is that fat phospholipid will form a membrane by throwing it inside of water. If I change the color here, let me use a blue. If I have water here all over the place, what will happen is that the tails, the hydrophobic tails, they will run away from water, and they are going to be ending up getting together over here in the middle. So they basically get together in the middle, they run away, and they are protected from water by the hydrophilic heads. This here is not a phospholipid, but something similar called a detergent micelle. Detergents are amphipathic. Actually, detergent is a molecule that is amphipathic because it has a hydrophobic tail and a hydrophilic head. And it behaves in the same way as phospholipids. If you throw it in water, it will make a tiny little micelle, a little ball like this. Phospholipids, it will be pretty much similar. If I throw phospholipids in water, if I have here water all over the place, the heads, they are going to be loving water, they face the water, but the tails, they run away from water, so they stay here inside. Let me put another color so you can see it better here. I have the tails all over here, and they are running away from water. So they make this tiny little micelle that you see here. However, what happens if this micelle is so big, so big, so big that some water enters over here? Ooh, that's not going to be good, because the tails, they are happy now because they are away from water. But if we make it really big, they have to find a way to exist with water. And the way is to put phosphate heads showing no points into the water. So what will happen is that the hydrophobic part that run away from water and the hydrophilic part that met water, they are going to be having to make an arrangement, okay? So in this example here, hydrophilic part protect the hydrophobic from the water. That's how it works. But if I put more water over here, then I will need more hydrophilic heads to protect it. And this is what's going to be happening. If I have this micelle being way too big, what will happen is that water will be here inside, water will be here as well outside, and then what will happen is that the micelle will be a bilayer of phospholipids. What will happen is that you're going to be having a phosphate head facing the water inside, the tails face each other, and then phosphate heads facing outside. So I have here hydrophilic heads facing water, hydrophobic tails running away from water. This here is the idea of a phospholipid bilayer making membranes. Actually, this will be the membrane. If we get this here really big, if we make this here really big, what will happen is that it will look like this. So this here is going all the way over there. Let's put another color here. So this here is going all the way over there, coming back and coming here in a very big micelle, which we call a cell, a membrane, or a vesicle, whatever that's made by membranes. And what we have here is that facing water on the top and on the bottom, we have the heads. So we have here many phospholipid heads. And running away from water, over here we have the tails. So we have the tails that are running away from water. So a membrane is made by a phospholipid bilayer, just like the one that you're seeing here in front of you. Two layers of phospholipids, head, tails, head. Two phospholipids face each other, so the tails get protected in the middle and the heads get exposed to the water. Okay, so you have water over there. That's how they work. Okay, so in a membrane, it will work more or less like this. What we have is water outside pointing the hydrophilic face over there, and you have water inside with the other hydrophilic part over there, and in the middle over here we have the fat part, the hydrophobic part, which will be here in the middle. This will be more or less what it looks like when you have a phospholipid bilayer. Okay, so this is the idea. Phospholipid bilayer is going to be made by a hydrophilic head, hydrophobic tails, hydrophilic head again. This is the idea of the phospholipid bilayer. So hydrophilic heads, they protect the hydrophobic tails from water. The hydrophobic tails, they are repulsing water, so they push the tails together and they keep the entire membrane together. So the membrane actually is kept by this, by the heads protecting the tails repulsing water, so getting attracted to each other, so they get together. A membrane is nothing more than a bunch of fats that are forced together by water. So because of water, they have to stay together. So they may move slightly. It looks like a carpet, so we call this fluid, because they can kind of move away, kind of move around, but they cannot move away. So a membrane is very difficult to break it apart, because if you break it apart, water enters into the hydrophobic parts and they don't like it, so they stay together. This is the idea. Okay. One thing that you might be good if you are capable of is to explain how these molecules, the phospholipids, help to maintain the structure of the membranes. So it looks like a very big question with no very big answer, but the idea, the trick here is to go into parts. Okay, so the structure of the phospholipid is a hydrophilic phosphate head and two hydrophobic lipidic tails. So this is how they look like. A drawing is always a good idea. So you show there the hydrophilic head, the hydrophobic tails. This is how they look like. Okay. Additionally, the phosphate heads, they isolate the lipid tails from the water. They face the water, so the tails are kept together by the repulsion to water. So tails are kept together, so they make the membranes to stay together, while the hydrophilic heads are protecting them, are isolating them from water. Okay, this will form a bilayer. A little drawing can be useful, although it takes a little bit of a while to make this drawing. But a bilayer, with two layers of lipids, of phospholipids, with the tails facing inside, the heads facing outside. So describing how this goes, that can be a good idea. The tails stay in place, holding the membrane together. And finally, lipids, they are held together, but it allows a certain flexibility. Okay, so they can move a little bit around, so they can be flexible, but they stay together. This is how the phospholipids help to maintain the structure of membranes. I hope you have enjoyed the class and have fun doing this quiz, and I will see you in another class.